Okay, more talk about our exponent rules. Exponent rules. Before we get started on the negative exponent rule that we covered today, let's do a little review and chat about our exponent rules that we have learned so far. We started with the product rule. And the product rule tells us that anytime we are multiplying like bases, we add our exponents. So, like bases, that's our big number, we add our exponents. So 4 to the second power times 4 to the third power equals 4 to the fifth power. All I did was add my exponents, which, if you expand this out, makes sense. 4 times 4, 4 squared is 4 times 4, times 4 to the third is 4 times 4 times 4. So all I did was expand each of those out, and I get 1, 2, 3, 4, 5 fours, which is 4 to the fifth. So product rule, that's the first exponent rule that we covered last week. The second one is the quotient rule. Quotient, can't spell this morning. Quotient rule. The quotient rule tells us when we are dividing like bases, we simply subtract the exponents. So, in this example, I have 4 to the third power divided by or over 4 to the second power. If I expand that out, I get 4 times 4 times 4 on the top, and then on the bottom I have 4 times 4. You can simply cross out each one you have on the top for one on the bottom, and I'm left with 1 4 on top, which is just simply 4. Or I could have just subtracted 3 from 2 and got 4 to the first power. You could write 4 to the first power, but you really don't need to. It's just an invisible 1. So, the next rule that we learned is our power rule. And this one's pretty cool because it really enforces what we already know about exponents. So the power rule tells us that when we are raising a power to a power, we multiply the exponents. So for this example, I'm going to do 2 to the third power raised to the third power. So 2 to the third power raised to the third power. What this means is, I'm going to expand it out, it's 2 times 2 times 2, that's one of those, times 2 times 2 times 2 times 2 times 2 times 2. I'm going to grab a different color so that I can highlight what you're looking at here. So here's 1, here's 2, here's 3. So 2 to the third once, 2 to the third twice, 2 to the third a third time. So altogether I have 1, 2, 3, 4, 5, 6, 7, 8, 9 twos, which makes sense because the power rule tells us when we are raising a power to a power, we simply multiply our exponents. See if I can fit in a little multiplication sign there. So 2 to the third power raised to the third power is 2 to the ninth power. And remember, if you're ever stuck, you can always write it out, expand it out. So 2 to the third power raised to the third power is 2 to the ninth power because I get 1, 2, 3, 4, 5, 6, 7, 8, 9 twos. 2 to the ninth power. Okay? I'm going to move over here to review our fourth exponent rule that we've talked about, and that's the zero power rule. Now remember, like we talked about yesterday, sometimes it might be referred to as the zero exponent rule or the zero power exponent rule. Power and exponent are interchangeable words that mean the same thing. So a power is an exponent. When you're raising something to a power, that's the exponent that you're raising it to. So the zero power rule tells us anytime we have a zero power or a zero exponent, it equals 1. So 7 to the 0 power equals 1. It doesn't matter if this number is 7,482 to the 0 power, it's equal to 1. No matter what the base is, when you have a 0 exponent, it equals 1. It could be x to the 0 power, and it would still equal 1. So those are the 4 exponent rules that we've covered and we've practiced. Today in math class, you learned, hold on just a minute and grab another sheet of paper. Today in math class, you learned the negative exponent rule. So this is our 5th exponent rule. Negative exponent rule. And the negative exponent rule tells us anytime we are raising something to the negative exponent, we simply do 1 over the base to the exponent. Sorry guys, my dogs have obviously started to bark like crazy. So 4 to the negative second exponent, we simply take our base and our exponent, we put it below a fraction line, and we put a 1 on top. Let me show you one more. So 3 to the negative third power equals 1 over, take your base and your exponent and just put it below. Just like that. So let me show you how and why that makes sense. If we look at something like, let's look at x to the third divided by x to the fifth. So this is our quotient rule. And remember, our quotient rule tells us to subtract the exponents. So x, 3 minus 5. Let's take a look at that. 3 minus 5 would be x to the negative second. Guys, if you're stuck on integers and you need to draw a number line, go ahead and do that. I'm going to make myself a quick little number line right here. I have a 0, a 1, a 2, a 3, a 4, a 5. Over here, to the left, I have my negative numbers. This isn't perfect, but it'll do for right now. If we were in class, obviously, we'd have a nice pretty one on the wall. But here's my number line. And if I'm at 3, I start at 3, and then I'm going to take away 5. So when you take away, you're going to move to the left. So if I'm at 3, and I move to the left 5, 1, 2, 3, 4, 5, I end here at negative 2. So I get x to the negative 2. Well, we can't just leave a negative exponent. We can never just say it's simplified with a negative exponent, because the negative exponent rule tells us we can further simplify it. So now that we looked at this, I want to show you x to the negative second. Let's draw that out. X to the third over x to the fifth. Let's see how the negative exponent rule makes sense. I have x to the third on top, so that's x times x over x to the fifth. X times x times x times x times x. Okay, now remember, for every one that's on top, you can take away one on bottom. So I'm going to cross that out, and left with 2 x's on the bottom. We can't just leave the top empty, so we would put a 1, and then our 2 x's on the bottom, x times x, which is the same as 1 over x squared. Okay, so that is how you would expand this out. X to the negative second would be 1 over x squared. Okay, so we were able to use our quotient rule and what we know from our quotient rule to help us solve the negative exponent rule. This one is probably the most tricky of all, so let's